So we've worked with sequences and series. Now let's focus on one specific type. So let's look at this example. Find the 50th term in the sequence 3, 7, 11, 15, forever. So if you notice, what's the pattern to get from one term to the next? It's pretty obvious if we're adding 4 each time. So one way a student could answer this question is just to grind it out. 3 plus 4 is 7, plus 4 is 11, plus 4 is 15, plus 4 is 19, plus 4 is 23, plus 4 is 27, plus 4 is 30. I'm exhausted. That doesn't seem like a good way, because I have to get to the 50th term. Alright, well, if we can use technology, maybe a calculator would be useful. I'm starting with 3. The pattern is add 4 to the previous one. So I press enter, and that gives me the second term. If I press enter again without typing anything, it's going to run the previous command, which says take the answer and add 4, which is the pattern. So when I press enter, this will give me the third term, which is 11. So I keep pressing enter, the 4th, 5th, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. There's the 20th term. We only have to go to 50. 21, 22, 23, 24, 25, 26, 27, 28, 29, 30th term. 31st, 32nd, 33, 34, 35, 36, 37, 38, 39, 40. I'm almost there. I only have 10 more to go. 41, 42, 43, 44, 45, 46, 47, 48, 49, 50. Now hopefully I didn't miscount or press the enter key twice by accident when I counted once, but I'm guessing 199 might be the answer. So I'm going to write that down. Looks like it might be 199. So that wasn't so bad. A little annoying, but not bad. But what if we wanted to say, let's find a pattern, let's generalize, let's figure out how to make this easier. Well, to get from the first term to the second term, we added 4. To get to the third term, we would add another 4. To get to the fourth term, we would add another 4. So wait a minute. To get to the fourth term, we're adding 3 4s. To get to the fifth term, we're adding 4 4s. To get to the sixth term, we're adding 5 4s. So to get to the 50th term, we would take the first term and add how many 4s? Well, let's see. To the fifth term, we added 4 4s. So it seems like we're adding 1 less than the term number. So the 50th term, it seems like it makes sense that we would be adding 49 4s to the first term to get our answer. And we know the first term is 3. And 49 times 4 is 50 times 4 minus a 4, so 200, 196. And then we add 3 to that, and we get 199. Aha! And that matches. That's what we thought it was. And that would have been a little quicker than keep pressing enter on the calculator. So in general, let's generalize this. To get the nth term, we're going to start with the first term. We're going to add the difference between the numbers, let me just call that D, the difference between the numbers times 1 less than the term, so n minus 1 times that difference. Now, using that, we should be able to get any term. So if I want the 17th term, I'm going to take the first term plus 17 minus 1, or 16, times whatever the common difference is in our sequence. In this case, it was 4. So that leads us to a particular special type of sequence called an arithmetic sequence. A sequence is arithmetic if a sub n plus 1 minus a sub n equals d for all values of n. So in other words, the easier way to think of this is the difference between any two terms is always a constant. And we're going to call that constant d for the common difference. And so this formula, which we just generated, the nth term is going to be the first term plus n minus 1 times that common difference. And so now with this formula, we should be able to tackle any problem that deals with an arithmetic sequence. Alright, so before we dive into some particulars, let's make sure that we can identify what type of sequence is arithmetic. Alright, so which of these are arithmetic, which means we add a common difference. Okay, so let's look. To get from -4 to 3, what did we do? Well, we have to add 7. How about to get from 3 to 10? Oh yeah, we add 7. And 10 to 17? We add 7. So this is an arithmetic sequence, and the common difference is a positive 7. Alright, how about the next one? We're at 1, we get to -1. Well, we had to subtract 2. But then we go -1 to 1, that's adding 2. And then 1 back down to -1, that's subtracting 2. Adding 2, subtracting 2. That's a pattern, definitely, but it's not the pattern we're looking for. We're looking for adding the same number every time or subtracting the same number every time, not alternating. So this one is not an arithmetic sequence. How about the next one? 2 to 4, that's adding 2. 4 to 8, we're adding 4. Well, already we know this is a problem. 8 to 16, adding 8. 16 to 32, adding 6. So this is definitely not an arithmetic. We're not adding the same amount each time. But there is another pattern here if we don't think of addition. How about we think multiplication? 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. There's a multiplication pattern going on here. We're multiplying by the same number each time. That's actually another special type of sequence that we're going to be interested in, and we'll study that next. That's called a geometric sequence. But for now, that's not arithmetic, so we move on. Alright, so how about this one? 11 to 6, we subtracted 5. 6 to 1, we subtracted 5. 1 to -4, minus 5. -4 to -9, minus 5. This is an arithmetic sequence. This time your common difference is a negative value, it's -5. Now, make sure that you're checking all of these. Don't just do the first two and say, you know, oh, minus 5, yeah, it's good, it's arithmetic because it's the same. You have to make sure that you check all of them. If the last one, for example, was -8 here, then that would be -4, and then it would not be arithmetic. So you do have to check all of them before you decide if it's arithmetic or not. And then how about the last one? That's one of my favorites. This confuses students sometimes because you say, well, no, we're not adding anything. It's just 1 all the way across. Well, let's be more technical. We're actually adding 0. So we are adding the same thing every time. So this is an arithmetic sequence. Your common difference is just 0. All right, let's jump to some examples. Find the first term, that's a sub 1, and the common difference, that's d, of the arithmetic sequence in which the second term, that would be a sub 2, is equal to -2, and the 8th term, a sub 8, is equal to 40. So we know the second term and the 8th term. How do we get the first term and the common difference? Well, if you're a formula person, which I don't advise just always diving into formulas without having understanding, but the formula we learned was that the nth term is the first term plus n minus 1 times d, the common difference. And yes, we actually could use this to work this problem out. Let's start with, we have a sub 2. So a sub 2 is going to equal a sub 1 plus n minus 1, so 2 minus 1 times d. And then we can plug in some values. So we know what a sub 2 is. A sub 2 is -2 equals a sub 1, which we don't know, plus 2 minus 1 is 1, times d, which we also don't know. Alright, now let's use the a sub 8. A sub 8 is equal to a sub 1, using the formula, plus 8 minus 1 times the common difference. So now if I plug in the values I know a sub 8 is 40, a sub 1 I don't know, 8 minus 1 is 7, and then the common difference I don't know. So what do we have here? I have two equations with two variables, Well, that's a system of equations. And I guess I could solve that. Use elimination, because the a sub 1's are going to cancel. So negative 2 minus 40 is negative 42. A sub 1 minus a sub 1 is 0. And then 1d minus 7d is negative 6d. So when I divide by negative 6, I get d is equal to 7. And then I can figure out the first term by plugging that into one of my two equations. I'd probably use the first one because it's simpler. And if I plug in 7 for d, then I know a sub 1, how can I write this? A sub 1 is going to be negative 2 minus 7, which is negative 9. And then I've got my two answers that they asked for, so we're done. Okay, and that's great. It works. Some people like to do that. Let me put all this over to the side for a second. Shrink that down. There. All right. And that works for you. But I want you to consider another method. And this is the way I like to do this. So we're dealing with 8 terms. So I'm just going to put a blank. A sub 1, a sub 2, a sub 3, a sub 4, a sub 5, a sub 6, 7, and 8. So this is the first term. This would be the second term. Here's the 8th term. And I have values. I know the 8th term is 40. And I know the second term is negative 2. Just from there, I can figure out what the common difference is. Because to get from a sub 2 to a sub 8, I'm adding the common difference once, twice, 3 times, 4 times, 5 times, 6 times. So if I take negative 2 and I add the common difference 6 times, I should get to 40. Notice, that's the same equation I had when I solved my system the other way. I'm going to add 2 to both sides, I get 42, divide by 6, I get your common difference is 7. And then to get a sub 1, well, instead of adding 7 to move to the right, I'll subtract 7 from a sub 2, negative 2 minus 7, and that gives me a sub 1. So, different ways to find the answer. Either way is fine, but I think it's important that you understand conceptually what's going on. Don't just try and memorize formulas. All right, let's try another example. Write a formula for the nth term of this sequence. All right, we want the nth term. We have the first term, a sub 1. And to get to the next term, what do? We add 3, add 3, add 3. So the pattern is add 3. So that's our common difference. So I know a sub 1 is 14. I know my common difference is positive 3. So the nth term, a sub n, well, I'm just going to take my first term, which is 14, plus n minus 1 times the common difference, which is 3. I guess I could clean this up a little bit. I could distribute and combine like terms. So I'm going to wind up with 3n, and then minus 3 plus 14 is plus 11. And so now I have a formula for the nth term for this particular sequence. Okay, find the 20th term of the arithmetic sequence if the second term is 9 and the 8th term is 51. So once again, you can set it up. I like, since they're not that far apart, I'm just going to use some blanks. So a sub 1, 2, 3, 4, 5, 6, 7, 8. This is a sub 8. This is a sub 2. And they gave us those values. A sub 2 is 9. And the 8th term was 51. It's an arithmetic sequence. We want to find a sub 20, which is way over here. So how can I find that? Well, first of all, let's find the common difference. To get from the second term to the 8th term, we have to add the difference once, twice, 3 times, 4 times, 5 times, 6 times. You could just do 8 minus 2 to figure that out. So if I have 9 and I add the common difference 6 times, I should get 51. So we get 6d equals 42. So d is equal to 7. So our common difference is 7. So therefore, I know the first term is going to be 9 minus 7, because I'm going backwards, and so that's going to be a 2. So a sub 1 is 2. So to get the 20th term, a sub 20, that's going to be the first term plus 20 minus 1 times the common difference. So my first term is 2. 19 times my common difference, which is 7. So the 20th term is going to be 7 times 19. So that's 70 and 63, 123, plus 2 is 125. Did I do that right? 70, 63, no, it's 133, sorry, 133 plus 2, so 135. 135. Always double check your work. Okay, looks good. Let's try another one. Could you also have done this with a system of equations like we did before? Yes. Okay. The fifth term of an arithmetic sequence is 3. So a sub 5 is equal to 3. The 50th term, oh gosh, a sub 50 is equal to 30. Wow. Well, that tells you from the fifth term all the way to the 50th, we've only gone from 3 to 30. That means our common difference has got to be pretty small. It's going to be less than 1, isn't it? Okay. Find the sum, wait a minute, find the sum of the first 10 terms. So what are we going to do here? Well, writing out blanks isn't going to be good because I need to get from 5 to 50. There's not enough room. That's too many blanks to work out. So here's a couple of ideas. Here's the idea I like to do. So let's start with this. A sub 5 is equal to 3, and a sub 50 is equal to 30. Let me find the common difference. To get from 5 to 50, I'm going to have to add the common difference how many times? Well, from 5 to the 50th term, that's 45 times. 45 jumps, 45 blanks. So if I'm at 3 and I add the common difference 45 times, I should get to the 50th term, which I know is 30. So if I subtract 3, I get 27, and then divide by 45, I get my common difference, and that makes sense. It should be less than 1. We talked about that at the beginning. It's good to have a ballpark idea. 9 goes into both of those, so that's actually 3/5. So I've got my common difference is 3/5. Okay, now, the first 10 terms. Well, I know the fifth term. Now, let me give you a visual here. First, second, third, fourth, fifth, sixth, 7, 8, 9, 10. So here's your first term. Here's your fifth term. And here's your 10th term. Now I know the fifth term already. They gave that to me. That was 3. So I guess I could simply add 3/5 each time to fill in the blanks. I could get 3 and 3/5. And then I add 3, and then I'm going to get 3 and 6/5, so that's 4 and 1/5, etc., and keep going. And then I'm going to have to add all these together to come up with the sum. So maybe it would be nice if we had an easier way, or if we could figure out a general formula for getting the sum, then we could make this happen. Now, by the way, let's back up for a second. If we know the common difference is 3/5, let's switch to, how about blue? I know that a sub 5 is equal to a sub 1 plus 5 minus 1 times the common difference. And a sub 5 was 3. I don't know a sub 1. And I know the common difference was 3/5. So I can figure out the first term. It's going to be 3 minus 12/5. That'll be my first term. So that's 15/5 minus 12/5, which coincidentally is 3/5, the same as our common difference. So the first term is 3/5. And then we can just keep adding as we go. So I guess we could punch it out by hand, do a little crunching, but let's try and figure out a formula to get a series. All right, the sum of a finite arithmetic sequence. So let's call this sum S sub n. It's going to equal the first term plus the second term plus the third term plus the fourth term, so all the way out, all the way to the nth term. Alright, maybe I'll say n minus first term and then nth term. Alright, so we're going to add all those together. Now, there's way too many variables here. So, using that formula, let me rewrite each of these. So let me say that S sub n, let's switch colors here. Let's say S sub n is going to equal a sub 1. Now what's a sub 2? Well, a sub 2 is equal to a sub 1 plus 2 minus 1 times d. Put that in parentheses. And then plus a sub 3. What's a sub 3? Well, a sub 3 is a sub 1 plus 3 minus 1, 2 times d. What's a sub 4? That's a sub 1 plus 4 minus 1 times d. Keep going. What's a sub n minus 1? Well, that's a sub 1 plus n minus 1 minus 1, so n minus 2 times d. And then the last one, what's a sub n? Well, a sub n is a sub 1 plus n minus 1 times d. Now you're thinking, where are we going? This seems even worse than what we had before. But at least now we only have 3 variables. We have a sub 1, we have n, and we have d. Okay, so now what I'm going to do, watch closely, it's going to get tricky. Now I'm going to write s sub n again, except I'm going to write it in reverse order. So I'm going to write this term first. So a sub 1 plus n minus 1 times d. And then I'm going to write this term next, a sub 1 plus n minus 2 times d. What would the next one be? It would be a sub 1 plus n minus 3 times d. And we keep going, and eventually we're going to get down to these last couple, and we're going to get a sub 1 plus 2d, and finally we'll get, oops, no, we got 3 more, a sub 1 plus 1d, and then lastly we have a sub 1. Okay, so now look what we have here. We have a giant mess. Yes, we do. So when you have a giant mess, what should you do? Let's add it all together. What's s sub n plus s sub n? Well, that's 2 s sub n's. All right, now let's add this first one here. Let's match all these up. So the first one here with the first one here. What do I get when I add those? Well, I'm going to get 2a sub 1 plus n minus 1 times d. Alright, now let's add the next two. We're going to add this quantity to this quantity. Well, we're going to get 2 a sub 1's again. A sub 1 plus a sub 1. So we get 2 a sub 1's. Now this is where you have to think. Now, what do we have? We have 1d plus n minus 2 d's. So how do we add those together? Think of it this way. What if I said add 3d plus 4d? What do you get? Obviously you get 7d, no problem, right? All you did was you added the coefficients 3 plus 4. Same idea here. Add the coefficients 1 plus n minus 2 times d. Well, that's going to simplify to n minus 1 times d. Wait a minute. Oops. Let's get rid of this. So n minus 1 times d goes right here. Okay, hey, that's the same as the first term we wrote. Alright, let's do the next two. So let's do this one. It's going to match up with this one. Those matched up. So they're all going to match up. So when I add these, I'm going to get, lo and behold, 2a sub 1 again. And then how many d's am I going to have? Well, I have 2 plus n minus 3. Well, that gives you n minus 1 again, times d. And it keeps going. Let's jump to the second from the end. That's going to match up with this one, second from the end. And we have 2a sub 1's. And then we have n minus 2d's plus 1 more d. So n minus 2 plus 1 is n minus 1d. And then we combine the last two terms here, and we get 2a sub 1 again plus n minus 1 times d. Alright, so we've got the same term over and over and over again. 2a sub 1 plus n minus 1 times d, 2a sub 1. How many of these are we going to have? Well, look up at the top here. We had 1, 2, 3, 4. We have n of those. So what we really have here is 2s sub n is going to equal n of these 2a sub 1 plus n minus 1 times d's. Now that looks a lot simpler. Now if I just divide by 2, I now have a formula for the nth, for the sum of the first n terms in an arithmetic sequence. And so now I don't have to, like in that last problem with those fractions, try and add all these things together. If I know n, and I know a sub 1, and I know the common difference, I've got my formula. So here you go. We have just generated this. We've proven it actually. S sub n is n over 2 times the quantity 2a sub 1 plus n minus 1 times d. Now this formula you'll see a lot in textbooks. Sometimes you'll see a variation. Look at this 2a sub 1. What if I split that up and wrote that as a sub 1 plus a sub 1? Now look what we have. And I highlighted in red what I want to focus on. When I split up this 2a sub 1, one of those a sub 1's plus the n minus 1d, does that look familiar? Yeah, that was our formula for a sub n, wasn't it? So this formula for s sub n, I could really replace the a sub 1, the red, stuff in red, I could replace that with a sub n. And so we have a second formula, which is actually the same as the other one. They represent the same thing. But two different formulas, and use whichever one you want. It kind of depends on what you have. The first formula, we need n, we need a sub 1, and we need d. For the second formula, we need n, a sub 1, and a sub n. We don't need d for the second formula. So I guess it depends on what the problem is giving you, decide which one you want to use. So now we can jump back to this problem that we were working on. That wasn't it. There it was. The fifth term of an arithmetic sequence is 3, and the 50th term is 30. So where were we at? We were trying to add up the first 10 terms. Well, what did we know? Well, we know that d was equal to 3/5. We know a sub 1 also wound up being equal to 3/5, just a coincidence. Now we didn't figure out a sub 10, although we could have, but I think that's all we need. And we know we're looking for the sum of the first 10 terms, so we know that n is equal to 10. So we've got everything we need. We have a sub 1, n, and d. So using that formula we just generated, s sub n is equal to n over 2 times 2a sub 1 plus n minus 1 times d, and we're ready to go. S sub 10 for this particular sequence is going to be n 10 over 2, 2 times a sub 1, which was 3/5, plus n minus 1, so 10 minus 1 is 9, times the common difference, which was also 3/5. And we work that out and we have our answer. So 10 divided by 2 is 5. We have 6/5 plus 27/5. So that's going to give us 33 fifths. 5 times 33 fifths, the 5's cancel, and we're going to get 33. And there we go. So now we can figure out any particular term, we can figure out common difference, we can figure out sum of terms for an arithmetic sequence.